morning all of you. The last class we discussed how we factorize using common factor method and by regrouping method. One more method is there, it is very important method, factorization using identities. Okay, now if you got an expression, an algebraic expression, then if it is in the form of, if that expression, if it is have three terms, okay, we know the three identities, standard identities we know. A plus b whole square equal a square plus 2ab plus b square. A minus b whole square equal a square minus 2ab plus b square. And also a plus b into a minus b equal a square minus b square. This main standard three identities we know. And if the given expression is in this form, okay, if the given expression is in this right hand side form, then we can factorize, we can write its left hand side, then that will be the required factorization. Suppose expression is given, one expression is given, x square plus 8x plus 16. Okay, now we observe this algebraic expression. We can see it have three terms. Okay, three terms is there, and also we want to check the first term and the third term. Okay, when we check the first term and the third term, that two terms are perfect squares. You know, x square is a square of x and 16 is a square of 4. So these two terms are perfect squares. Then we can change this expression in the form of a plus b whole square. We know a plus b whole square is equal to a square plus 2ab plus b square. That is the first and the third term is perfect squares. And we want to check, can we write this second term 8x as in the form of 2ab. Now in this case, instead of a is what? Instead of a is here x. Okay, in the standard form a plus b. So instead of that a, if it is here x, and instead of b, it is here b square. The last term is b square. So if the term is, what is the square root of 16 we know? 4. So b will be equal to 4. Then can we write the second term 8x as in this form 2ab that we want to check? That means 2 into a is what? Here x. X into b is here 4. Now 2 into x into 4, that we know 2 into 4 8x. So that is the third term in the given algebraic expression. Now we can find out it is in the form of a right hand side of the standard identity of a plus b whole square. So we can write its left hand side. What is the left hand side of a square plus 2ab plus b square? A plus b whole square. Just like this also we can write as in the form of a plus b whole square form. That is the required factorization. So instead of here a, we know that is x. So x plus, then instead of b here it is 4. So x plus 4 whole square. So this is the required answer. The factorization form of x square plus 8x plus 16 is equal to x plus 4 whole square. For that, first we want to check, here have three terms. Okay, it has three terms, and also these three terms are positive. So if three terms are positive, then we will use the first identity. If this is the second term is negative, then we will use the second identity. Okay, and if the given expression is have only two terms, then we can check this will be in this form, a square minus b square form. Then we can write the right hand side of that a plus b into a minus b. Now after checking that, if it has three terms and if it is if these three terms are positive, then we check the first term and the third term are perfect squares or not. Here the first term is perfect square and the third term also a perfect square, that is the square of 4 is 60. So here instead of a it will be x and instead of b it will be 4. So we can write it as x plus 4 whole square. Now consider another example. Here another example is given. 4y square minus 12y plus 9. Okay, now first we check it has 3 terms. Okay, it has 3 terms and the second term is negative here. And also the first term is a square term, perfect square. Then it is a perfect square of, we can rearrange this 4y square as 2y whole square. Okay, and this third term we can write it as 3 square. 9 instead of 9 we can write it as 3 square. So then we want to check the 12y, how we can write as the 2ab form. 2ab form. So 2 into a is what here? 2y. 2 into 2y into b is 3. So we will get this 12y. Look at it. 2 into 2 4, 4 into 3 12. So minus 12y. That is the second term in the given. So here it is in the form of a minus b whole square form. So its left hand side, how we can write? Its left hand side we write it as a minus b whole square form. So here instead of a is here 2y and instead of b is here 3. So 2y minus 3 whole square. Okay. So in this type we want to check. For this first we want to check it is the first term and the third term, are they perfect square or not? If they are perfect square, then only we can use this identity. Now another question, you look, factorize 49p square minus 36. Factorize 49p square minus 36. Now you look here only 2 terms are there. And 2 terms are perfect square. So we can write this is in the form of 49. It is the square of 7. And p square is the square of p. So instead of 49p square, we can write it as 7p whole square. And instead of 36, we can write it as 6 square. Now it is in the form of which? A square minus b square. In this form, a square minus b square. So what is his left hand side? How we can write? A square minus b square, we know a plus b into a minus b. So instead of a is here 7p. So 7p plus 6 into a minus b. 7p minus 6. So this is the required factorization. It is very easy. If it is a square term, both are square term. That we want to check. That is must. Now different questions are given here. Now another question, you look. M raised to 4, factorize m raised to 4 minus 256. This also only 2 terms, and then we check, are they perfect squares? We know m raised to 4 is the square of which number? M square. So we can write it as m square whole square. And 256, it is the square of which? 256 is the square of 16. So that we can write it as 16 square. Now it is in the form of a square minus b square, where a is equal to here m square and b is 16. Okay, then what will be its left hand side? Like this, a plus b into a minus b form. A plus b, that is m square plus 16 into m square minus 16. Okay, now we can again factorize this m square minus 16 if it is possible. Now it is again in the form of which? A square minus b square form. So instead of that, we again factorize this m square plus 16, we can same as that. Then this is in the form of a square minus b square, that is m square minus 4 square. Instead of 16, we can write it as 4 square. Now again it is in the form of a square minus b square. So a square minus b square is a plus b. M plus 4 into m minus 4. So instead of this term, we can write it as m plus 4 into m minus 4. So this is the required factorization. So in this way we can do different questions in the textbook is given. Now one different question is that all are same type. One different question I will show you. This is question Now you look at this question. 63a square, factorize. All the question is factorize. Factorize the given expression. 63a square minus 112b square. Now look at this. Now is it 63 and 112? They are not a perfect square. That we know. Okay, 63 is not a perfect number and 112 also not perfect square. But we can convert that into a perfect square form by taking one number outside. What is the common factor in 63 and 112? We know if it is 7 when we take outside. 9 into 7 we can, that is 63. So 9 is a perfect square. Just like when we take that 7 is in outside. Here remain 9a square. Okay. And 112 by 7 you will get 16. Okay. So 16b square. Okay. Now if it is not a perfect square, then we want to think about if any common factor is there, and if we take outside that common factor, when we take outside, then it will convert into a perfect square form. Now here it is in the form of a square minus b square. How we can write it as? In here a is 3a whole square. Okay. And 4b whole square. This way we can write that. Now it is in the form of a square minus b square. So what is that? How we can convert that? 7 into 7 is already there. A square minus b square is a plus b. A plus b, 3a plus 4b into 3a minus 4b. So this is the required factorization of that. Okay. And another question also there. One separate question we can see. Now you look another question. 16 x raised to 5. 16 x raised to 5 minus 144 x cube. Now we know 16 is a perfect square and 144 also a perfect square. But x raised to 5 and x raised to 3, they are not perfect square. Then when we take one x as common outside, what will happen? If when we take one x outside, here remain 16x raised to 4 minus here remain 144 x square. Okay. Now the variables are in the perfect square and the coefficient also. 16 is the square of 4 and 144 is the square of 12. So we can rearrange this as 4x square whole square. Okay, 4 is square is 16. X square whole square is x raised to 4 minus 12x whole square. 12 square is 144. X square is this. Now it is in the form of a square minus b square form. Okay. Now we can write it as again a square minus b square. We know a plus b into a minus b. Here a is 4x square and b is 12x. So a plus b, that is 4x square plus 12x. A plus b into a minus b, 4x square minus 12x. Okay. In this way we can factorize the given expression as to the required factorization form. Okay. If done some questions I give in the textbook as homework, all of you do that. And already I give the examples, exercise questions I already done in the notebook also. If any doubt in this solving, you can ask and clear your doubts. Okay, thank you.